All right, so today we're going to be learning about cookies and sessions. So up until this point, we haven't had the ability to log in or out of our application. We've been able to save data in the database, but we haven't been able to securely and reliably associate that data with its owner. Today, we're going to be learning about, So most modern web applications require users to log in and start a session so that they can only modify their own data. Today, we're going to be learning about related concepts and technologies that are used for logging into a web application, such as cookies, sessions, and password hashing. Later this week, tomorrow, we'll be learning about some of the tools that Django provides that make it easier for us to implement authentication in our own applications. So to kind of repeat myself a little bit here, today I'm going to be showing you how you can implement authentication in your application, signups and login, registration, password hashing. I'm going to do this all manually just so you can see how it looks. And I just want to be clear about something that commonly in the industry, what I'm about to show you today is referred to as a very bad idea. The idea that I'm going to be creating my own authentication system by hand. You basically never do this. You should always prefer to use tools that other people have written that have been tested thoroughly and used in production extensively by lots of companies, so you know that they work, so that you know there aren't any vulnerabilities and you're not going to get hacked because of your buggy authentication system. But just this once, just today, I'm going to show you building an authentication system by hand, just so you can kind of understand what's happening underneath the hood. But please understand that in your careers, you're not going to be actually doing this by hand. You're going to be using powerful tools that are able to manage all these logistics for you. All right, so the first concept that we're going to have to learn about are cookies. So I'm sure you've all heard of these before. You've seen those like cookie warnings that show up on many web pages these days. Can anyone just give me a quick definition of what a cookie is? And I'll give you mine. Anybody heard these before?
Isn't it just data that's stored on your computer or stored on their website? One of the two?
The first one. So a cookie is a bit of data that's stored in the user's browser. So you might remember that previously when we were talking about HTTP, I discussed it as being a stateless protocol, meaning that by default, we don't automatically know if multiple requests are coming from the same user. So the way that modern applications remember who you are across different pages is by using cookies. So there are two common definitions for cookies. So two common definitions for cookies. It can be a small piece of data that's stored in the user's browser.
All right. Evan, that's a good question. I think someone answered it at some point, but I'm not sure. Sorry, Raphael.
So primarily, we're going to be using this first definition. I'm going to be showing you how to use the set cookie HTTP response header. I just want you to be aware of the fact that sometimes, especially like in tech journalism or other contexts, the term cookie is used in a less formal, less precise way to just mean any technology that can be used for tracking users on the web, similarly to how the formal technical browser cookies work. Were there a few questions in the chat?
There was just a question about why the word cookie is used, which I was just Googling, and which is interesting, but we don't need to talk about it right now.
Is there a simple explanation for why the name was chosen?
Apparently there is. It was coined by web browser programmer Lou Montulli, according to Wikipedia. It's derived from the term magic cookie, which is a packet of data a program receives and sends back and forth unchanged, used by Unix programmers. And that term supposedly comes from fortune cookie, which is a cookie with an embedded message. So the fortune cookie bit actually is kind of interesting.
Okay, that's funny. So I didn't know that, but given that they are cookies, I know that this metaphor gets carried forward and is repeated in a lot of other places. Like you'll hear about stale cookies, you'll hear about cookie jars. So other technologies really run with this metaphor of cookies, which I think is kind of funny. Okay, so just to go through the basics of how this header works, the basic flow is when client sends a request to a server, the server responds to that HTTP request. There are headers on that response. It can include the header set cookie with any number of key value pairs as its value. Then, if the user sends another HTTP request to the same server, the user's browser will automatically send all the cookies it was given in the set cookie response header by including them in a cookie request header.
Yeah, and a lot of you are probably familiar with being able to clear cookies in your browser cache. And just to emphasize what Raphael was saying, cookies are stored on your computer when you close and reopen your browser and stuff. So they're cached and stored.
And critically, when you revisit that same website that set those cookies, your browser will automatically resend those cookies back to that same server. And so that's essentially how a server is able to identify repeated users across multiple visits, is because your browser is automatically sending this data back up when it was instructed to store it in the first place.
And for a lot of sites, when you don't necessarily log out and then you go back to the site 2 days later and you're still logged in, there's a good chance they're using a cookie to implement that.
Yeah, very likely. So let's see. There are also, beyond just storing key value pairs on the cookie, there are a few options that you can set on the cookies that change how they behave a little bit. But before we talk about specifically what these options are for cookies, how we can configure them, I would like to build a tiny little Django application just so we can actually send some HTTP requests and actually see these cookies instead of just having you listen to me talking about them. Let's switch gears and do that real quick. We're going to create a virtual environment. This auth intro. We will use it. Source. And we can install Django. Cool. Now we can scaffold our application. Project. And we're going to call this doesn't really matter what it is. Let's imagine that this is a blog that I'm creating. And so I'm going to call this blog project. Cool. It's got my blog project. I'm going to create an app. Before I forget, we're going to register the app. And then in the urls.py, I'm going to do my usual setup here. Including blog app.urls. So now I have to create that. File urls.py. Just grab these imports real quick. Actually, just grab all this. I got to build my index view. I'm going to create a template for my index HTML. Let's slash blog app. Index HTML. My blog. Okay, so let's try running this, see if I haven't messed anything up yet. Cool. Welcome to my blog. So it looks like my homepage is set up. I can render the template, so that's great. Gonna open up the network tab here. Just look at what we're sending and receiving here. Yeah, actually, let's do this in incognito. Okay, so one thing that's going to make developing with cookies a little bit tricky is that, like I said before, your browser automatically resends cookies to the same server. But because I'm just developing at localhost 8000, my browser thinks it's the same website as the last time I was at localhost 8000, which, you know, we as developers understand is not true. That's just the URL that all of our local websites are going to have. So in order to not get my cookies confused with a previous project, I'm doing all of this in incognito. So when I open this window, I get like a fresh set of cookies unconnected to any previous browsing I've done. So that's going to give you just a simpler, easier environment for debugging these kind of cookie-based applications.
Yeah, it's not the worst to just use an incognito browser all the time for development.
Yeah, I basically do that. I mean, sometimes I forget to, but there's no reason not to. You could do all of your development in incognito, and I think you'd be better for it.
Yeah, I maybe with like some of the extensions for like React, they might not be there, but that I don't remember, to be honest.
All right, so anyways, I'm looking through the network here, and I just want to point out that currently there's nothing about cookies in either the request headers or the response headers. No cookies here at all. So that's great. That's exactly what I was expecting. So let's go back to our code and go to our views. And we're going to do a little bit of printing here. We'll just print request.cookies, see what that looks like. Going to refresh the page real quick, go back to Python, and we have an empty dictionary. So we're seeing here that Django knows what we're talking about. It's able to show us the cookies we asked for, but currently we have none. It's just an empty dictionary. So next, I'm going to create another route where we can set some cookies. So I've got two routes now. They're both going to render the same template, but they do different things before that. All right, so let's see what this looks like. Actually, I've needed to make a URL for this index, set cookies. Call this set underscore cookies. What is the problem here? Is that it? Okay, there we go. Just forgot a comma. All right, so I've reloaded the home page. Again, we have no cookies here. None at all. I'm going to go to this route / set cookie. Set cookies is actually where I'm going to go, plural. So now we're going to take a look at the network tab. And so this is my first request to this set cookies URL. So in the request headers, what I sent up to the server, still nothing about cookies here, because my browser did not know that there were any cookies for this website at the time that I sent this request. However, when I got the response back from the server is telling me that I should set some cookies. Gives me this header here, set cookie, foo equals bar, that's this one key value pair. And then also path is / saying that this cookie is valid on the entire website. So Django kind of added this in for me by default. But this is the information here that I actually wanted to set, foo equals bar. So looking back in my code, setting this cookie here, the cookie key is foo, cookie value is bar. So yeah, in the response header, it's telling me now to set this cookie. Clear my screen here. Now I'm going to refresh the page here on set cookies. So now when I inspect the request, the response is still the same. It's still telling me to set this cookie, but in the request, now we're sending that information back up to the server. So now in the initial request that my browser is sending to our server, it's sending that same information back up. Foo equals bar is our cookie. And if I go back to the home page, it's localhost 8000, in the response header, we're no longer getting that set cookie header. The home page doesn't set cookies. Only the set cookie route sets the cookies. But in the request header, we're still sending the cookies because resending the cookies isn't specific to one path within a website, but it's global to the entire web application. So even though I'm at the home page, this page does not set cookies. It's still part of localhost 8000. So we're going to continue sending these cookies back up every time we revisit any page in this application. And then back in my Python server here, when we print request.cookies, now we can see that that key value pair was added to our dictionary. We've got key of foo with a value of bar. So this is the most basic flow of how cookies operate. It's going to get a little bit more complicated from here. Does anybody have any questions about what we've done so far?
Would you ever set specific cookies based on different web pages, or is that just pointless and dumb?
How do you mean?
Like, would you ever have like cookies based on different views, or is it just something that you would have to have set for every route in your website?
I mean, typically you only set the cookies when the user logs in. And then those cookies are used to track the user across all the different pages on your website.
Cool. I just didn't know if there's like any other functionality for cookies that maybe isn't as common, but doesn't really sound like it.
I mean, I'm sure you can do them for a lot of different things other than just logging in, signing up, but that's definitely the most common use for them. And honestly, once you have a login for a user, any other information that you need to store can just be stored in their user account in the database. So you don't really need to use cookies for anything other than remembering which user from the database is visiting your site.
Thank you.
Yep.
I'm sorry if this is not a well-worded question, but I'm getting a little bit confused on, you sent, my understanding of it at least is like on line 10, you set response equal to the rendering of the home page. And I'm just confused on basically adding .set cookie to that rendering. Like I'm just getting confused on that syntax. Can you speak to that a bit? I'm sorry, that's not super well worded.
Mhm. So it's kind of similar to before, how we were setting the status codes for our responses. Like first I create the response and do that by rendering an HTML template. And so this response object here is going to have the actual HTML that I want to send to the client. But as of line 10, it has not yet been sent. So I still have the opportunity to add some options to this response, change a little bit about how I'm going to respond to the client. So I could, set a status code here if I wanted to be something other than 200. But in this case, I want to change some of the headers for the response. So before I send the response to the client, I'm going to use the set cookie method to change the set cookie header that's set on the response. And then after I've set that, then I can actually return the response to the client.
Okay, and that .set cookie, is that just common syntax for setting a cookie, or because it looks like that's your function, but is that how you would always set a cookie, is just .set cookie?
Commonly, yeah. So I'd say I'm never going to do this at a lower level than this. So like when you see the actual cookie string, where was it? Like there's a little bit more syntax to it. It's like there's a semicolon in it and then the path equals slash or whatever. So there's like a little bit of syntax to it. I didn't actually have to write the whole cookie by hand. So I just need to know that the cookie has a key and it has a value. And then Django kind of figures out the rest of the syntax for me. And this set cookie method is built into Django. So the response that you get from render or from HTTP response or JSON response, that has a set cookie method on it. But as we're going to see in the near future, there are other ways that we can get Django to automatically manage these cookies for us. So we basically just say like, hey, Django, we're using sessions. And then Django will automatically set and check these cookies for us as appropriate.
Okay, thanks.
Mm-hmm.
If we wanted to send more than one key value pair, how would we do that on line 13? Or can we send a whole dictionary?
Let's take a look. So now we set cookies. So from the server, there are two different set cookie headers. One is foo equals bar, one is foo2 is bar 2. So we get in the response from the server, two different set cookie headers for the two different calls to set cookie. But in the request, those get collapsed. So the request only has one cookie header where both of those key value pairs are put into one line separated by semicolons. But again, I don't ever have to worry about that bit of syntax because the browser and Django handle that part automatically.
Okay, thanks.
Mm-hmm. All right, so like I mentioned before, there are a few different options that we can set on our cookies to kind of change how they behave. So the most important option for cookies is max age. And that determines when the cookie expires. So these cookies do not have a max age set. So I believe that either means that they never expire or that they expire as soon as I close my window. I can't remember which one it is, but the moral of the story is that you should be setting the max age if that's actually something that matters. So let's just take a look at what that looks like. Okay, so here, now the set cookie still says foo equals bar, but it also tells us that it expires Monday, July 11th, 2022 at this specific time, and also the max age is 5. So I'm pretty sure this is 5 seconds. So another convenient thing that Django has done for me is I didn't have to specify the exact moment in time when the cookie expires. I just say how long it should last for. And then Django computes, okay, well, I know what time it is now. The cookie lasts for 5 seconds. So just 5 seconds from now, that's the expiration date. So I appreciate not having to do any time math myself. Django just kind of figures it out. But so also now we have a temporary cookie that only lasts for 5 seconds. So I've definitely been talking about this for more than 5 seconds now. So if we look in the request header, when I sent this request, we sent foo equals bar and foo2 is bar 2. But as I refresh the page, now the request only has foo2 equals bar 2 because that had no expiration. Whereas foo equals bar, this expires in 5 seconds. So because I was talking for more than 5 seconds, this cookie had expired. And our browser was able to detect that, like, hey, we've got this cookie, it belongs to this domain, but it's stale. The cookie has passed its expiration, so we're going to delete it instead of sending it back up to the server.
Quick question, Raphael. So
Yeah.
it looks like it says it'll expire at 15:04. Isn't that 5 hours?
GMT.
GMT. So it's not central time.
Gotcha.
Yeah, definitely got to be careful about time zones when you're dealing with time.
Yeah, it gets tricky too, because like if you create a cookie, like the time zone that the server's in, it becomes relevant.
Yeah, for sure. And for other purposes too, the server's time zone is relevant. Just, it's important to know what time zone you're in.
It might be cool to show them the cookie in the application tab too, real quick.
Sure. So yeah, what I was showing you before was just the raw data getting passed back and forth between the client and the server. And I think it's very important that you're able to read that so that when your authentication is not working the way you want it to be, you can look at the data that's actually being passed around and
Agreed.
debug that.
Yeah.
But granted, assuming that things are working and you want to have like a cleaner view and just an easier to read understanding of your application, in the application tab, you can look under cookies and it'll show you all the cookies that your browser knows about, and it'll be in this table. So it's just an easier way to read your data, I guess, especially if you have a lot of cookies.
You can delete them, I think, too, here if you need to for some reason.
Oh, can we?
Yeah, you can.
yeah.
Oh yeah, you can edit it. You can do all sorts of stuff.
So I've never done that before, but I imagine that could be pretty useful for testing and debugging and whatnot.
Yeah, I think at some point that's where I ran into it. But I definitely agree with you about like feeling comfortable looking at like that request response information in the network tab. I usually like always have the network tab open when I'm kind of doing web app development.
Yeah, network is definitely my like top 3 favorite tabs, I would say. Probably console, elements, and network. Maybe console, network, and then elements. Not sure what I use most.
Yeah, yeah, it's cool. We're all becoming browser like power users now.
Yeah. But anyway, so I just showed you this cookie expiring. So, in the request header here, just says foo2 is bar 2. So now I'm going to refresh this page twice in less than 5 seconds. There's 1 refresh, there's 2 refresh. So now the request actually has both cookies in it. So that's how max age works. It's very important for determining when your cookies expire. And depending on what kind of application you're building, different max ages might be appropriate. So 2 examples that come to mind immediately are if you're building an application for a bank, you definitely want to make sure that if like a user is logged in, they're actively sitting in front of their computer. You don't want a situation where someone walks away to go to the bathroom and someone else sits down at their computer and they transfer $1 million to a different bank account really quickly or whatever. So for that reason, for like banks and other kind of sensitive financial applications, cookies tend to be very short-lived. So if you're not constantly using the application, every 5-10 minutes or whatever, they're going to force you to log in again, just for your security. Now that's going to be different from like a social network, which doesn't need quite as much security. You're not like doing your banking or managing your healthcare through there. But what they need is for it to be as easy as possible for you to use the site, so that if you have 5 seconds free in the middle of the day, you can spend those 5 seconds on Facebook or wherever. And in order to make that as easy as possible, they want you to essentially never log out. So you'll log in to Facebook once and they'll set a cookie that basically never expires. So that way, for as long as possible, you can just go back to facebook.com and you're already logged in, you're already reading posts and posting other stuff and looking at ads and stuff like that. So you just have to consider the use case if you value security or convenience more.
Raphael Cayley had a good question in the chat that like those messages you are about to be logged out, they're based on like cookie expiration, and I think they can be. Is that right?
Kind of. So I don't know if those messages are actually like looking at your cookies specifically and checking like when they're going to expire versus the current time. I think it's just generally like the developers know that the cookies are set for 5 minutes. And so they also have a JavaScript timer that counts down 5 minutes after the page loads.
Yeah.
So I don't think they're like actually connected to each other in a hard way. It's just there are 2 different timers set for the same amount of time.
And actually thinking about it too, like what's got to happen is you've got to have like somewhere in the database, you've got to store like when a user logged in and like what time the cookie becomes expired. Because the other thing to bear in mind about cookies, like any information that gets sent to the browser is by definition insecure, because as you can see, like we can very easily edit and modify a cookie. So like we can make a cookie say whatever it wants. So if a cookie is being used for any sort of user authentication login type purposes, like we have to have some corresponding information in the browser. That's our source of truth to like compare it against.
Yeah, cookies are great for convenience, but as we will discuss later in this lesson, they open the door for certain security vulnerabilities. So we can't trust the client too much. We're gonna have to add some security onto our cookies here. So we can't just trust the users that they are who they say they are. So speaking of security, the other remaining options that I want to talk about relating to cookies are about security. So actually, before I change anything, I just want to show you real quick that you can generally access cookies in JavaScript. So if I look at document.cookie, it tells me foo2 is bar2 because the previous cookie is expired already. So I'm going to refresh the page. And now I look at document.cookie and it shows me both of them. foo2 equals bar2 and foo equals bar. And I think this actually updates in real time. So as I'm talking about this, I check it again, and now it's just foo2 is bar2 because this cookie expired while I was talking about this. But so the point is that you can access cookies in JavaScript by default, but generally speaking, you'll never need to do this. And it opens the door for certain security vulnerabilities. So figure if there's no reason for the cookies to be accessible by JavaScript, just ban JavaScript from accessing them. So the way we do that is by setting a flag called HTTP only. And I think this is kind of an odd name for it. Because HTTP only means that it's not accessible in JavaScript. Normally you can access the cookies from HTTP or from JavaScript. HTTP only means they cannot be accessed from JavaScript. I would have probably called this option something like not JavaScript, but whatever, I didn't get to design this. Okay, so I refresh the page, go to document.cookie, and it only shows foo equals bar. If I go to the application tab, we can still see foo2 is bar2. But because it's an HTTP only cookie, I cannot access it from JavaScript. So that makes this cookie slightly more secure. Still potential problems that can happen, but now there's a whole class of security vulnerabilities that we are not vulnerable to because JavaScript cannot access this cookie. And now we don't see any cookies because this one expired and the other one was HTTP only. Note though, that in the near future, we're going to be handling the CSRF token that Django expects using JavaScript. So it's going to be a cookie and we're going to read it using JavaScript. So we will actually see an example in the near future of a cookie that we do not want to be HTTP only, that we do want to access through JavaScript. But that's going to be like one specific exception that I will show you and call out at that time. Other than that, you really don't need your cookies accessible from JavaScript. And then lastly, this one's going to be kind of hard to demo. So there is a flag secure equals true or false. That means that this cookie should only be used over HTTPS. So it's a little bit hard for me to demonstrate this because we're just working locally. So I don't have access to HTTPS until we actually learn deployment. So I can't really show you the difference between having this at true or false because we don't have HTTPS. But generally speaking, you're going to set all of your cookies to secure equals true because your website should only be used over HTTPS. Serving it over HTTP just opens the door for certain security vulnerabilities.
Are folks familiar with HTTPS? Raphael Alicia has a question.
Yeah, you had your hand up. Alicia, what's your question?
Yeah, so I understand so far the cookie basically just says this is the same user. And so like application wise, it makes it easier to like load things because you've already been there, whatnot. How, since it doesn't store somebody's like login information, how exactly can a cookie be exploited? Like what could somebody do with it if they had it?
So first of all, if they like have your cookie, like they have the actual string, like in that case, I could just go to the application tab and find the cookie for like user ID or whatever, and then just change the value and I would be you. Like I would refresh the page and it would show me your information and I could, you know, edit everything that is yours. I'm logged in as you at that point. That doesn't really happen very commonly. What's more common is that people are exploiting the automatic behavior of cookies. So imagine, for example, that you log into facebook.com. And so when you log in, they set cookies on your computer that have like your user ID, basically, or like a session ID, so that when you send more requests to Facebook, you don't have to log in again with every request. They can recognize like, oh, this person is already logged in. They're connected to this user in the database. So this is their related data. This is what they can edit. This is what they can't edit. Great. And so every time you send a request to Facebook, those cookies get transmitted automatically, just, you know, to save you the trouble. So here's where the exploit comes in. Let's say I want to ruin your day and I send you a link, maybe like in an email or something, that's facebook.com/reset password. So if you click on that link, and let's say, you know, just clicking on this link is enough to reset your password. When you click on that link, since it's you clicking on it with your browser, that's going to send your cookies up to facebook.com automatically. And it's going to like actually reset your password or do some other destructive action on your account because I tricked you into clicking a link. And so it uses your cookies. Does that make sense?
Yeah.
Do you want to ask a follow-up question or are you good for now?
I'm good for now, thanks.
Cool. What other questions do we have about cookies? We're going to move on to sessions next, but I'd like us to take a break before we do that. So let's just take a minute here, ask questions about anything that we're unclear about so far.
Could you explain again what you did when with the example where you refreshed it twice within 5 seconds?
Yeah. So I set an option for the foo bar cookie, max age is 5. So 5 seconds after that cookie is set, it will expire. So if I refresh the page faster than 5 seconds, then the cookie is still good. It gets resent automatically. But if it takes me longer than 5 seconds to refresh this page, then the cookie expires and it'll no longer be sent back up automatically.
So every time you refresh it, it was just like setting the clock to 0 and
Yep.
Okay, got it.
Mm-hmm. Do we have other questions? All right, so why don't we take a break now? It's 10:20, come back at 10:35, and we're going to learn about sessions. All right, so when we left off, we were learning about cookies, which are the actual specific technology that are used for transmitting data back and forth between clients and servers. And so next I want to talk about our sessions, which are not really a specific technology, but it's an experience or kind of a user flow that is created when we use cookies in a specific way. So, often when a user interacts with a website, they expect that their actions and preferences are going to be remembered. For example, if you mute a video that autoplayed in a news article, you might hope that the website remembers that preference and also mutes the videos for other articles that you read afterwards, even if you're not logged in. Also, many shopping websites allow users to add items to their cart, which persists across pages, again, even without logging in. These are both examples of sessions in which we use cookies to create a consistent user experience across different pages of our site. So it's important to note that sessions are distinct from logins. Many sites will create a session for you as soon as you visit before you log in. It's also possible to have logins without a session. For the front end of a website, this would create a pretty bad user experience since you'd have to log in again every time you load a new page. But for an API, this is pretty normal since you often need to use an API key to authenticate every single request. Now, we can potentially try storing session data on the cookie itself, but cookies have a very limited size. So instead, we're just going to store a session ID in the cookie and then store the rest of the user's data on the server. So for that, I'm going to make a new view here. I'm going to create an empty dictionary to keep track of my sessions. Just print them out at the start of this, just to double check where we're at, what we've got. And so let's see. First of all, when a user comes to this page for the first time, they're not going to have a session. Well, let's just try to fetch it anyway, just so we can see the code from top to bottom. So someone's going to come to this view, this URL. We need to get their session ID number from the sessions dictionary. Or I'm sorry, from the cookies. So ideally, if someone has an existing session, this is how we're going to access it. We get their session ID number from the cookie that they're sending. And then we use that session ID number as the key for this sessions dictionary, which is going to actually have the rest of their data. Of course, for the first request, they're not going to have a session. So we need to be prepared to create one. So if this variable doesn't exist, we get null or none out of the sessions dictionary. We will create a session for them. And create some random numbers here real quick. So I'll import random. So the session ID number is going to be a random 6-digit number between this 100,000 and 99999, or a 7-digit number. Yeah. So that'll randomly generate a session ID number, and we will add a property to our sessions for this user. I need to import date time as well, just so I can print the current time. Okay, so if they do not have a session, we generate a random number, and then we use that as a key in our sessions dictionary. And we just keep track of the count. This is how many times they visited the page, and the start time, which is when they first visited the page. This is when we created their session. So else, if they already have a session that exists, and we're able to find it on line 30, and then instead, we just grab the count from their session and increment it by 1. But either way, I'm going to use the index again. I'm not actually sure if I need a different template for any reason. Probably get all this done with one template. Now remember, when we render a template, we can pass in a dictionary of data. And so I'm passing in not the entire sessions dictionary, but I am using their ID number to get their specific session. So it should be just, this object, basically, the one for this particular user. And then we will set a cookie. And we return the response. Just a second. Now I need to make a URL for this. So let me just make sure this is working. Cool. So I go here once. Tells me I visited this page one time since time zone is wrong, but this is, the time when I visited first. If I refresh the page, it tells me I've been here 2 times. But now I'm going back to my non-incognito window. So here in my regular window tells me I've been here 1 time because the regular browser window has a different set of cookies from my incognito browser window. So here I can keep refreshing this page and it'll count up. I've visited 10 times with this cookie, but here I've only been here 3 times or 4 times. So because there are different sets of cookies for my incognito window versus my regular window, that is showing me a different session from my sessions dictionary.
Also, I just want to throw in a gotcha that I learned the hard way and through a manager related to this, which I'm not 100% if Chrome still does this, but as of like a couple years ago, at least, different incognito tabs in Chrome would share a cache, which I don't know if that's a good or bad idea. I'm not sure if that means that they share cookies. Does this ring any bells with you, Raphael?
Yeah, they do share a cache. So that's an important thing to keep in mind, is that all of your incognito windows share one set of cookies. So that can potentially be a gotcha, because if you open 10 incognito windows and then close 9 of them, your cookies still exist from those incognito windows. So if you forget to close that 10th incognito window and then you open up a new one, that new incognito window is going to have your old cookies from the previous 10 that you were working with. If you want to actually get a fresh set of cookies, you need to close all of your incognito windows and then open a new one.
Yeah. Or just delete the cookies.
I guess you could do that too.
But yeah, and in a lot of ways, just closing and reopening is better. Okay, so I wasn't sure if cookies get shared between incognito browsers, but it sounds like that's correct.
Yeah, that's a good thing to be aware of. I've definitely, wasted time in the past because I did not know that. And so I've come to learn that the hard way.
Yeah, same. And Caleb is asking in the chat to see your HTML in.
Okay, thank you.
Yep. And I also want to point out real quick, this is what the sessions looks like on my server. It's one dictionary. Right now there's 2 dictionaries inside of it. This one is, the first session, count of 3, it starts then. And then this is the other session with session ID, count of 10, starting at this other time. So I'm keeping track of all the different user sessions in this dictionary on my server. So this is the general concept of sessions. This is a simple way that you could implement it. Not that you would do this practically. I just want to show you what a session actually means, what is happening under the hood. And this is basically it. User shows up to the page and we have to figure out, if they've been here before, do we know who they are? Check to see if they have any cookies. And so, step 1, we'll check the user's cookie. They might provide one, meaning that they think they're logged in. And then we'll check their cookie against our sessions to confirm that we think they're logged in. And then if we're actually able to find this session ID number inside of our sessions, then we determine that they are actually a valid logged in user. And then in that case, we just increment their session count by one, because that's all this application does, is just count repeated visits. But if they've not already started a session, then we start one for them. Give them a session ID number, and then start the generic session with count of 1 and start time of now. But in either case, we are setting the cookie of session ID number so we can remember them when they come back. Make sense to everybody?
Yeah, that explanation helped a lot.
Cool, I'm glad. So moving forward, we are gonna, so let's see. So this is a very simple implementation of sessions. The problem with this, though, is that it only works for a single route. And the whole point of sessions is to persist the state across different pages. So I could just repeat this logic across all of our routes, getting the session ID number, checking if they have a session, setting the cookie and whatnot. I could just repeat that logic across all of our different routes. But in order to keep our route handlers dry, that is, do not repeat yourself, we need to use something called middleware. So middleware are basically just functions that run in the middle of things. Figure when a user sends a request to our server, what they're trying to get at is the endpoint. What they want are these functions here, like increment count or index, are endpoint functions is what they're really looking for. But before they actually get to the endpoint, there are a bunch of functions that we can run in the middle called middleware. So what we would like to do is use some middleware that will basically just apply this logic to every single request automatically. Now, in general, I think it's a good skill to have to know how to write custom middleware for your server. So if these kinds of problems come up and you need to perform some work on every request to your server, then you can do that with middleware. It kind of set some like default behaviors that happen for every single request. However, implementing sessions is such a common need that Django actually has some built-in middleware that accomplishes this for us. So if we look over in the settings.py, there's this middleware section. We haven't really bothered with it much before, but one of the things that's built in is session middleware. So it's already built in Django, it's already installed, it's already listed in this middleware section. We just have to invoke it from our route handlers. However, Django stores the sessions in the database, not in memory. So we're going to have to set up our database real quick here. All right, so I want to, where am I? Blog project. So we're going to make migrations. That's not how you spell that. Great, can't do that because I don't have psychopg2, so we'll install that. right. Now we will make migrations. Can't do that because I don't actually have this database auth intro. So I'm going to create that. Create DB. So I don't actually have any of my own models, so it didn't make migrations, which is fine. So now I'm just going to migrate. Great. Okay, server's working again. I'm gonna just take a look with pSQL here. Got a few tables here, just kind of the default tables, because I haven't made any of my own models. But I just want to point out one of our default tables is Django session. Let's start from Django session. And right now there's nothing because there are no active sessions. But let's change that. So in use.py, we're going to refactor this increment count view. Going to make it behave the same way, but using the built-in Django sessions instead of implementing my own.
So when you start this, is this what we'll be actually using, or we also won't be using this, we'll be using something else?
This is something that you can use, but it's not the primary way that you'll be managing user sessions. The Django authentication, like built-in auth features, are very powerful. So that can manage cookies and sessions and like user accounts for you and such. So if you're just trying to access data that's on the user's account in the database, you don't really need to think about the sessions explicitly. But if you want to like save temporary data that should just persist for the user session, but not like stored in the database long-term, then you can do what I'm going to show you now. So I do think this is a useful technique to know, but it's not something I do every day.
I agree with you, Raphael. And I would add that I think I think it'd get tricky pretty quickly to use like the Django built-in stuff without kind of understanding how it works. And that being asked about like implementing a basic user session is a question. I don't know if it would come up in an interview or not, but it certainly wouldn't be like way far out of left field. Like you would be expected to understand this stuff. I think. Does that vibe with your guys' take, Raphael and Zainab? Because actually I want to check in on that.
Sounds about right.
Just curious, will we have to do this for our next assessment, or is this strictly just so that we can speak to it when we're doing interviews and stuff, and just so that we know about it?
I mean, it's nice to understand what a session is for interviews. You might actually use request.session sometimes. This is, a nice technique to know about. This is not going to be on the assessment though. The next assessment is just going to be Django and Django ORM. So the backend stuff we were doing last week, basically.
Okay, so like the validators and stuff like that?
Yeah.
I do feel like this stuff with cookies and kind of writing like a basic session is really core knowledge, because as soon as you kind of like get outside of like using like Django's built-in stuff for learning purposes, I feel like I just know that I've had to mess with auth tokens and cookies like all sorts of times, or maybe you need to add like a cookie for another reason unrelated to authentication or something like that, whether it's user tracking or something else. I feel like it just comes like the tools that we're kind of looking at now come up in a lot of different ways. I think I had to add, maybe it was like a token or something once to like figure out if the user, to identify if the user was on a mobile browser. I don't remember exactly what it was, but, or like on a mobile device. So this is good stuff to know, not to, what's the saying, beat a dead horse.
Let's just print request.session. Not sure if that's going to show us anything super useful. But anyway, this is this entire previous function here, that view that has been refactored now. So this behaves the same way. It's just less code. It's a little bit simpler because I'm using this built-in request.session. So this is built into Django. On the request object, there's a property called session, and it's just a dictionary. But if I add any data to this dictionary, then I can access that same data when the same user sends more requests in the future. So go to a new incognito window. Increment count, been here one time since that time. If I refresh the page, it still counts up, so that looks like it's working correctly. I'll just print out properties here. So yeah, I'm able to access the same data on my backend here using request.session count, request.session start time. It's just like a plain old dictionary. But the magic is just that from one request to the next, this dictionary persists. Normally, if I just declare any data for a given request, this bar or whatever, this only exists for this one request, and then it gets deleted after we send the response. So this is like really great that Django is able to handle this for us automatically. And if we see that on the network tab, let's see. So here we increment count. So now there's a new cookie that I didn't set specifically, but Django is managing this for us automatically. So you might be wondering, how does Django do this? How does it know that the same user has come back twice, so it gives you the right data in request.session? So the way it does that is if you assign something to request.session, Django is going to start a session for the user. It's going to set this cookie, session ID equals, and then this is an actual session ID. It's not a 6-digit number, it's a string kind of like this. And it has an expiration date. This is some default that Django sets. And then on subsequent requests, my browser is going to send that session ID back. And so Django, using the sessions middleware, it's going to take this session ID and then look up in the sessions database which dictionary this session ID corresponds with, and then it retrieves all that data that corresponds with it. So if we take a look in pSQL, now that I've actually created a session, now we've got some data in here. Let's see if I can display this a little differently. So currently there's one record in the Django sessions table. There's the session key, F0 GVD. That's this guy, F0 GVD. Okay. That's my session key. And then session data. I don't really know how to read this. I assume it's encrypted data, and Django under the hood is able to decrypt this data. So that's useful. And then of course, as the expiration date, based on the max gauge. So I don't normally have to look at this table and think about it too hard, but I just want you to know that Django is not performing magic. It's just keeping track of a few things for you automatically, but it's all just in the database or in cookies. It's all just data. It's all right here.
How would you change the max age using this data, this Django included thing?
Like this. Request.session.setExpiry, and then number of seconds. Sound good?
Yes, thank you.
So let's see, the next section of this lecture is about cookie vulnerabilities. Although we actually kind of talked about this a little bit previously. I think someone asked a question about this, but just to reiterate, because this is important, it's very convenient that cookies are automatically stored on the client and sent to the server, which means that when we're writing our front-end code, we have to basically do nothing to accommodate the cookies. It's all handled in our back-end code. But sometimes this automatic behavior can be exploited by hackers. So if a hacker tricks a user into clicking on a link that does something destructive, like resetting their password, the request will be performed with the user's cookies. Depending on other factors, a hacker might be able to delete your data or take control of your account. This kind of vulnerability is called cross-site request forgery, or CSRF, pronounced, like I just said, like you're surfing the sea. So to prevent CSRF exploits, Django will not process certain types of unsafe requests unless you provide a CSRF token, which is a small piece of data that must be manually sent to the server, unlike cookies, just to prove that the request was a legitimate request from a user within our application. In the near future, we will learn how to properly include a CSRF token in AJAX requests, but today we will just be temporarily disabling this feature. So I'm going to be using that CSRF exempt decorator that we've used in the past. A lot of activity in the chat. Do we have any questions?
Is there like a default session data, or do you have to specify exactly what data you want to get stored in the session?
By default, the session is empty. It's just whatever random data you want to remember about the user.
Okay, cool.
Mm-hmm.
So if you've been surfing the web for a while, you've been doing.
You're really quiet. I can't hear you.
Hold on. Is that better? Can you hear me now? I'll fix it. Never mind.
Try again.
Now, anything? Anyone? No.
It's still kind of quiet. Just I'll
Okay.
try to listen closely.
Well, I'll try to fix it first.
All right. All right, so so now that we can use cookies to create sessions, the next thing we want to do is register a user and log them in to start a session. Before we can create a user, we need to know how to properly handle user passwords. It's important that our users' passwords aren't stored in plain text, just in case a hacker gets access to our database. Django has a lot of built-in functionality that helps us manage users and their passwords. But today we're going to implement sign up and login manually so we can understand the process better. Now, the general process for registering a user is first, user sends a post request to the server with their email and password. Note that Django assumes that you're registering with a username and password, but in like modern applications, you're pretty much always going to register with an email and password. So there are going to be a few ways that I'm going to deviate from the Django defaults, just because I'm assuming that we want to log in with an email instead of a username. Okay, so next step. Server generates a random salt. So this is a random string of characters. And then we append that string of characters to the user's password. Then the salt plus password gets hashed. So we concatenate those two strings in one string, and then we hash that string. We create a user object.
Yeah, and this is great to learn, as this is pretty much how like usernames are hashed and stored everywhere.
All right. So send a post request being like, this is me, I want to register. Server generates a random string of characters called a salt. And then they concatenate that onto your password. They hash your salt plus your password together, create a user object in the database. And then for the password column, instead of storing your actual plain text password, they will store the hash of your salt plus your password, which has the hash concatenated to it, or which has the salt concatenated to it. So that might seem a little weird, a little redundant, because we use the salt plus the password to create a hash, but then we concatenate the salt onto the hash to store that in our database. And then optionally, we create a session for the user after they register. Now, technically, you don't have to do this, but generally speaking, in a modern application, users expect to be logged into an application after they register. If you have to like typing your password once to register and then typing your password again to log in, that just kind of feels redundant. So most users just expect to be logged in automatically when they register. All right, so let's make a model for our users. I'm not going to think too hard about this because Django actually provides special functionality for creating user models. So tomorrow, we're going to learn the more sophisticated way of doing this, where Django is able to handle things for us automatically. But today, it's just going to be a basic model in our database. All right, so there's our user model, pretty simple. They're just gonna have username and password. Now, like I was saying before, it's dangerous for us to store plain text passwords in our database. So this field here is not going to contain what the user actually typed in to the registration form. It is, excuse me. We want to limit how much sensitive data we are responsible for in case a hacker gets access to our database. So it's important to hash a password first and only store the hash in the database. Now, it's important to keep in mind that hashing is different from encryption. Can anyone summarize for me? Maybe you know this already. What's the difference between hashing and encrypting something?
One's one way, and the other's two ways.
Yeah, that's the most important difference, I would say.
Hashing goes
Didn't
one
you
way.
say-
It's hard to dehash something, but encryption and decryption, if you encrypt something, you have to be able to decrypt it.
Right. Maya, did you add something?
Oh, I was pretty much going to say that. I just remember you saying that if we hash it, that you pretty much can't reverse it.
Right. So that's, kind of the same thing that John was saying. One is a one-way operation. The other is a two-way operation. So anything that you can encrypt, you can decrypt. That's kind of the point of it. It should be reversible. So this is used for transmitting data so that after the recipient receives the data, they can reverse it, they can decrypt it into a legible format. However, hashing is a one-way process. There is no straightforward way to reverse a hash and recover the original value. I say there's no straightforward way because there is a process of reversing hashes into passwords, and that's called password cracking. And it's generally illegal unless you're a security researcher, but it's not a straightforward process. It's sleuthing and deduction and, problem solving. It's not like you just go from step A to step B or whatever, and then you can reverse the hash like you would with decrypting.
From my perspective, when I'm learning a new technology, like if I'm learning Django and I'm learning this cool feature that Django does where it does a lot of hashing for me, what I want to know is like what hashing algorithm is Django using? Or like what do the Django docs have to say about how secure that hashing is? And are there any gotchas for me? So that for me, that's something I would like look up when learning and using like a tool like Django in like a work environment. And then I would just file that away. Like I don't need to go into the details of the algorithm and stuff. Really, I just need to make sure that like it's in line with what the best practices are. And if I don't know what the best practices are, it's a good chance to Google it. Like I've needed to refresh myself, and I just Googled like how secure is hashing, and it brought up a couple of blog posts that are good and talking about like what are good hashing algorithms these days. And I just need to make sure that there's not any gotchas that I need to watch out for with Django and hashing. And then that's like kind of as deep as I need to go. And then I kind of stop there. That's kind of my approach to this stuff. I think it makes it a little slower sometimes when learning new things, but the flip side is you absorb a lot, and I think you have a lot of useful context.
Yeah, I think I did that once. I looked over the Django docs and they explained the hashing algorithm they use. And I said like, oh yeah, that looks like an industry standard best practice. I'm sure this is secure. And then I forgot what it was and kind of moved on. Just trust that security professionals are, smarter than I am with regards to this stuff. And they've put a lot of thought into like a very robust authentication mechanism.
Yeah.
But anyways,
Yeah.
sorry, just got a lot of content I want to get through here.
For sure.
So a couple of features that are important for a hashing algorithm. So I know that we talked about hashing in a different context previously, but so when we're hashing for passwords, there are a couple of things that our algorithm needs to do. So first of all, it must be fast enough that we can log a user in relatively quickly. Slow enough that a hacker cannot guess 1 billion passwords in an hour. And then also a secure hashing algorithm should produce hashes that look similar for all inputs, so a hacker can't get clues about the password based on the hash. All right, so that's hashing. Guarantees that we're not storing plain text passwords in our database. However, this is not a complete solution. There are still some problems, even if we are hashing our passwords. So imagine if someone who wants to, break into someone's account, even if we hash our passwords, a potential hacker would need to guess your password and then hash that guess. And this can be a little bit slow. However, a clever hacker might have a list of pre-computed hashes for common passwords. You can just Google like, top 1,000, 10,000 most common passwords and get a pretty good list. And odds are that like most of the people for random web applications are going to be using passwords somewhere in that list. So this kind of list of pre-computed hashes is called a rainbow table. And this saves the hackers a lot of time because hashing the password is the slowest part of making 1 billion guesses. So if the hashes are pre-computed, they can guess a lot of passwords much faster. Also, a hacker might notice that many users have identical hashes, which even though you don't know exactly what the password is automatically, if you notice that many people have identical hashes, that means that they used the same password, and it was probably a very common and insecure password. if you have multiple users that are just by chance using the same password. So the solution to these problems is adding a salt to the password. A salt, like I mentioned previously, is a random string of characters that's added to the user's password before it's hashed. So then we store the salt and hash in a single column in the database. This guarantees that every user has a unique hash and none of the hashes can be found in a rainbow table. Salting your password doesn't actually make it much harder for a determined hacker to crack a single secure password, but it mostly just prevents opportunistic attacks. It increases the amount of time and effort required to crack many weaker passwords, and just kind of adds another roadblock to potential hackers. So even though this is important to do, it's considered industry best practice, it doesn't make your passwords uncrackable. And especially like if you have a VIP or whatever, like, you know, the president has an account on your website and someone's trying to crack their account, salting the password is not going to do much to prevent like a determined government hacker from reversing one specific password. Right, next thing I would like to do is actually sign up the user for our application. So in the URLs, I'm going to make a path here. Sign up. Use dot up. Use, we'll make a route for that. So we're going to be receiving post requests from our users. So we're going to have to check out the body. Now we've seen this before a couple times. We need to import JSON. Let's see, how am I going to generate the salts here? Give me just a second. Okay, so like I said before, the salt is just a string of random characters. So I'm going to generate some random characters. Random 8-digit number, but as a string. So that's going to be the salt. Normally it's an alphanumeric string of letters and numbers, special characters. Our salt is just going to be numbers, just for simplicity. So we generate a salt. And we need to hash the password. In order to do this, I'm going to use a built-in hashing library in Python called hashlib. You don't have to worry about how this works. You're never going to be like manually hashing anything with this. This was just the simplest way that I could deliver this demo. So we're going to import hashlib. It's going to let me hash things. We're going to use the SHA-256 hashing algorithm, which is maybe not the very most secure. Maybe it's good enough still. I don't know. But it was easy enough to use. So I'm going to be using it for this demo.
I think it's okay. I was just looking. I realized I'm not up to date either.
Yeah, these opinions change over time. Some algorithms like are popular for a while, then they fall out of favor. Part of the problem is that computers get faster over time. So an algorithm that used to be slow enough might become too fast as computers get faster. So actually modern hashing algorithms have ways to just arbitrarily make them slower. I think it's kind of funny. Sometimes computers are too fast. All right, so don't worry too much about all this syntax over here. The important thing is that we are creating a salted hash password by hashing the salt plus the raw password. These are just strings. We are concatenating them together. And that creates our salted hash password. Now we'll create a new user. Send a JSON response, so I need to import that. We don't have too much to say in this case. I'm going to let the user know that their sign-up request was successful. Oh, I need to import the app user model as well. But yeah, so this is roughly how we register a user. I'm going to check the body for the password that they typed in, and we generate a random salt. We concatenate those together, salt plus the raw password, and then we hash that. And then we create a new user with their username, whatever they typed in, and then their password is going to be the salt again, concatenated to their hash. And then we save them in the database. So that is how we register a user.
Sorry if I missed this. Is app user a model you created?
It is. Models.py, app user, very simple.
Got it.
Yep, does almost nothing. Tomorrow, I'm going to be showing you how to use Django's built-in functionality for managing users, and it's going to do a whole bunch of automatic stuff for us. But that's not happening today. Just really simple basic model, 2 fields on it. So yeah, we still need to build the front end that's going to send these requests. And then I need to make some login functionality. But yeah, I think this is a good time to pause, take some questions, and then have a break. What questions do people have? You guys are real funny. But yeah, all this talk about salting and hashing, definitely make a lot of breakfast jokes when I'm talking about encryption. Terrence?
Yeah, okay. So line 75, the password part, salt. Yeah, I see on line 71, salt is generating a random number and you're adding that number to the other number.
So I'm converting the number into a string. So I'm not doing any math here. I'm just concatenating one string onto another string.
Okay, all right. And that doesn't alter the original password in any way?
Nope.
All right.
But it's important to remember then that like the original password is not what's stored in the database. You know, it's been transformed a couple times.
Got it. Okay.
What other questions do we got?
Do we need that $ on line 75?
So the purpose of this $ is just for visual separation, because there's two bits of information in this one string. There's the salt, and then there's also the salted hash password. Practically speaking, these are both going to just look like random strings of characters. So it's very hard to tell where one starts or where one ends and the other begins. So just for readability, there's going to be a $ just as a visual separator between the salt and the hash.
So is it safe to assume that this would be like connected to a form on a website and then you're using JavaScript Axios to grab those inputs and then pushing it through a URL that's handled by this?
Exactly. We will see that after the break.
Okay.
I know you kind of just went over it, but I guess I'm still kind of confused. If you don't save the actual password to the database, I don't understand, like, what is keeping track of the actual password?
Great question. So we'll see that when we get to the login, because the way that we like validate that a user is who they say they are is when they try to log in, they're going to give us their plain text password. And we can't directly compare that against the hash, but what we can do is just repeat this process again. So they're going to log in, they're going to be like, hey, this is my password. And so what we can do then is we go look up that user in the database and grab their salt because it's just right in the database, and then concatenate that to the password that they allege is their password. And then we hash that. And then in theory, that should match what is actually in the database for their user's password. So we cannot convert the hash back into the password to check if it's a match like that, but we can convert their password back into the hash again to check if those match.
So I'm assuming for your, like on line 71, would you have to have some sort of conditional statement since you're saying only do this if this is a new user? Well, yeah, because I guess this is the sign up, not the login. So yeah.
Yeah. Yeah, we'll make another view after the break to handle logins.
So where in the database are we storing the salt though?
The salt is stored in the user table. So, I mean, look here, I'm saving a new user. He's only got two fields, username and password. You know, in the model, we've defined them as just two fields, username and password. And, you know, he also has an ID, but don't worry about that. But the password has multiple bits of information in it. The password field itself in one string has the salted hash password. And it also has the salt itself. I think this will become more clear when we get to the logins after the break.
Yeah, and like with the hash, like if I put in my name, the string 80 AM into a hashing function, it's always gonna produce the same output.
Right.
And then the salt is random so that like there's less patterns in what a hash produces. But then when we have, and the way this password hash login stuff works is like, we do have to know the salt associated like with my name, so we can like produce that. So like I give my username and then the system like knows what salt to use. I think I might be getting that wrong. And we should take a break. I don't want to.
Yeah, I think kind of the critical thing here that's a little unintuitive for people is that the salt is just stored in the database in the password column right next to the hash. The salt is not any more of a secret than the hashed password. So I think some people get a little tripped up on that.
It does seem a little weird though, because I mean, like, is salt really stored? Isn't it just a part of the, isn't the only thing I could access from the user, either the username or the password? Like, how would I specifically get the salt if it's not saved to a variable?
Well, because the salt is in the password before it's $. You just have to do a little string manipulation. You know, you split the string on $signs, and then the first element is
Oh,
salt.
oh yeah, I kept thinking it was JavaScript and you needed the, but no, okay.
Oh yeah, sorry. This is not the variable interpolation string.
Yeah.
This is just a plain old $sign in the middle of this all.
Thank you.
Yep.
So what if the salt has a $sign in it?
Let's assume it doesn't.
I was wondering if the $sign's like typical convention, or do you just put anything to visually signify the separation? Like, do you use like a slash instead of a $sign, or like a pipe or something?
So the only times I've ever actually looked at a hash and tried to understand it, they've used $signs for separating the different pieces. So Django's hashes do that. And I think also bcrypt hashes do that, which is another hashing algorithm I've used in the past. There might be other conventions as well, but this is the only thing I've seen.
Thank you.
Yep. What other questions have we got? Caleb?
There shouldn't be a $sign in it because it should be in hexadecimal.
So when you, I might be getting ahead of the lecture a little bit here, but when you go to log in, the system pulls the salt from based off of your username and then applies the password input through the hashing algorithm and then adds the salt to it to compare to the salted hash password. Is that how that works?
Pretty much. I mean, they look up your user object with your username and then get your password from the user object. The salt is contained in the password field. And then they use that along with the password you sent when you signed up or when you logged in, and then hash those together and then see if it matches this. But again, I'm going to write out code for that when we get back from the break. So don't worry too hard if you can't visualize it.
Okay, no, that makes more sense. I was just making sure it's straight in my head. Thanks.
Mm-hmm. All right, so at this point, let's take a 10-minute break. It's 11:44. Come back at 11:55. We're going to go a little bit over this afternoon. I apologize, but it shouldn't be too much later than 12:30. So yeah, come back at 11:55. See you soon, folks. All right, so while we were gone over the break, I made a few updates to our little app here just to save us some time. Just going to walk you through real quick what I've built. Just preparing to have our front end for our site. So in our settings.py, we've got some static files that we can serve. Got my static folder, has some scripts for the login and sign up pages. And in my blog app, we have created templates for the login and sign up pages. They're both extremely basic. We don't even have a form here, actually. So in the interest of time, we're actually just hard coding the form we're submitting. So, normally the user would actually type into a form and we would have to get this information from the form inputs. But just in the interest of time today, I'm just hard coding this all in. So basically, when the user goes to the sign up page, there's not even a form. They're just automatically going to send a post request with this username and password. So it's if they're registering as Jeff Bezos with the password of dragons. And then on the login page, it's going to be the same thing. It's just going to, I don't even think I need this here. Just going to send this post request to /login as soon as the page loads. So we're not going to deal with the user input or the form handling. Just want to send data from the front end to the back end. So first I'm going to try to sign up. Look at my URLs. I have the sign up view. Okay, but I need to distinguish between someone sending a post request to create a new user versus someone sending a GET request to just view the sign up page, because those are different requests. So we'll just check if this method is get. Okay, so on a GET request to sign up, we just send them the sign up HTML. And if we get a post request to sign up, then we assume that they're trying to sign up, and then we'll process that data. Okay, we're still incrementing count, but I don't care about that. Let's go to sign up. Okay, got a forbidden error because I am not handling CSRF correctly. Yep, CSRF verification failed, request aborted, great. So like I said before, it's not my focus for today's lecture. So we are going to just ignore it. All right, so the sign up route does not have to abide by CSRF protections. Now I'm getting a 500 error. What is going on here? So this blog app user does not exist because I just created a model, did not make migrations, did not run migrations. So we got to do those things. Cool. Create the app user model. And we migrate. Looks good. Try signing up again. Okay, cool. So this time I got the success true came back. So I made a round trip from my client to the server to the client again. So on the server, looks like everything's successful, seeing all these 200 status codes. So that's great. So I'm going to look in my database and see if I can see this user now. Looking at my tables here, called it blog app user. So here is our user. Jeff Bezos is user ID 1. Their salt are these characters up to the $sign. And then their hashed password, which includes the salt in the hash, is everything here after the $sign. So that's cool. That's roughly what I'm expecting this user in my database to look like. So now the last remaining question is, how can we log in and tell the website that we are this person in your database? So I'm going to go to the, where is that? Oh yeah, in the views. So after sign up, I'm now going to create a login route. Dalton?
Where did you, in your generate salt method, where did you say how long you want the salt to be? I don't.
Just because it's a number within this specific range.
Oh, it's just, that's all one number. I thought it was like individual numbers, but that makes sense.
Yep. So this route is going to be CSRF exempt also.
All right, and this is the cool part.
So of course, first of all, if it's a GET request, we're just going to send them the HTML page. However, if they're sending a post request, that's because they're trying to log themselves in. And we will load the body. Look up the user. Do some string manipulation. So looking up the user, grabbing their password from the database, and then splitting it, because I know that that's actually two pieces of information. The first bit is their salt in split password 0, and the second bit is the actual hash, split password 1.
So I just want to make sure I understand when JavaScript sends this request to the server, are you using username and password here just because you know that that's what the keys would be called when it's sent to Django?
Yeah. So in the form, we're posting this object. This is our body for the request. It has 2 keys, username and password.
Oh, so the login would naturally be the same exact thing. Okay.
Yeah, so outside now I'm looking for username and password. All right, so this is the challenge hash. This is, the user logging in, alleging that they are who they say they are. And this is the hash that we're going to compare against what they have stored already in the database. So it's using the password from the form that they submitted, plus the salt from the database. Then we hash that together, and that should match what's in the database. Okay, so then when I log in, we check if the challenge hash is the same as the hash password, which we got out of the database. And so if those match, then we trust that this person is who they say they are. Then we set a cookie with their user ID and then send that back to the client. So now in the future, when they send a request to the server, they're going to be sending their user ID and a cookie. And so our server can say like, oh, hey, we know who this person is. We can just use their user ID and look up their user object from the database and then use all of their data for displaying useful, relevant pages to them.
So
go ahead.
Would you also in that same function create a session as well?
So that's what we're doing here when we set the cookie, is this is supposed to be creating the session. So the idea is that then all the other routes, like the index and whatever, can check for this user ID cookie. And that's how they know that there's an ongoing session, that they can connect that to other data.
Would that other data also be saved in your app users, or would you have like another schema for all of that?
There's different ways you can model it, but kind of what I'm imagining now is that, the cookie has the user ID. So that just lets you look up, the rest of the user model from the database. There are other ways you could set this up.
But I guess I mean like, so if this was like a real application, the user could actually do different functionality, would you put all of that inside of the app user model, or would you have a separate model that corresponds with like a foreign key to their username? Or I guess would it not matter?
I'm not sure if I understand your question.
Like, I guess it just mean like, so if a user's signing in, there's obviously going to be like user data that they need that's associated with their username. Where would you want to put all of that data? Would you put it on that app user, or would you have a separate model just to hold other information? I don't know if that makes sense. Maybe it's just a bad question.
I would think to put all that data in the app user model, if it's part of the user itself and it isn't part of something else, and just put it right in the same model. There might be logistical reasons though, why you would have a separate model for their user data. beyond just the email and password. And so that's actually something I'll touch on a little bit tomorrow, or maybe that's coming later. There are a few different ways you can set up users with Django. And one of the ways is actually doing what you kind of described, where you have separate user models for just like the username and password and then all the other user data. But I'm going to show you a style that I prefer, where we're going to have everything into one user model, where we're going to leverage Django's default behaviors as much as possible.
Thank you.
You're welcome.
Yeah, that's a good question. Definitely both ways are viable.
Oh, we didn't actually log in. So let's make this route. Cool. So it looks like I have logged in. Server tells me success true. So it looks like this code has all been run successfully. Yeah, I don't think there's anything else interesting in the database for me to show you at this point. But that is how you log a user in if they already exist in the database. So yeah, that is today's lecture. You're going to have a little bit of homework tonight. You're not going to have to re-implement all of this. I just wanted you to see this once to have an appreciation for what's happening under the hood. But your homework tonight is going to focus on just using the built-in request.session middleware in Django, because I actually think that that's useful. Yeah, it shouldn't be too crazy. Shouldn't be as complicated as this whole demo was today. Terrence, you have a question?
Yeah, can you scroll back down? So line 104, I'm not understanding how the challenge hash could ever equal the hashed password if hashed password is only the second part of the full password, but challenge hash actually has salt on the front end of it before it actually goes to the password. So how will they ever equal each other?
So the challenge hash doesn't have the raw salt in it. It's just that the salt is incorporated into the hashing. So before we hash, we add the salt to the password to create the challenge hash. But that is how the hash password was created in the first place. Because when we register the user, we combine the salt with the raw password, and that's what gets stored in the second part of their password column.
Okay.
So yeah, I know it's a little bit tricky to follow because there's a few different steps going on here, but basically we are recreating the steps that we did when we log in. We are recreating the registration steps every time the user logs in, just to make sure that what they supplied us hashes to the same value again.
I think it makes sense.
Yeah, it might be hard to understand just listening to me, but I think if you trace through the code a little bit slowly, that helps.
Yeah, that definitely does usually help. All right, thank you.
What other questions have we got? Luis, you're asking when you might use request.session rather than using the Django authentication system. So if you want to store session data that is not connected to a user in your database, it would be useful to use request.session. So for example, if you want to track a user before they've actually signed up, you would have to use request.session for that. So a common example is something I mentioned earlier in this lecture. If you have like an e-commerce site that has a shopping cart, for example, as many e-commerce sites do, you know, like it's very hard to let the user check out before they've registered. So you really want users to register for your e-commerce site before they actually buy things. But if you force people to register before they can do anything at all on your site, they're not going to like your site very much and they might just go somewhere else. So a compromise that a lot of websites do is they, on your first visit, they let you pretend like you're registered and they'll save your data using a session. But then before you like actually buy anything, you know, before you submit your cart or whatever, they force you to register at that time. So you can like go around the site from page to page and add a bunch of items to your cart, and you feel like you're shopping, you feel like you're already signed up. But then right before you actually go to check out, at that point, they'll ask you to register. And then when you register, everything that was in your session gets added to your user account in the database. So you can pretend like you were signed up that whole time, kind of. Cool, hope that helps.
Yeah, that's a great example, Rafael.
Yeah, and this example is assuming that the website does not have a continuous guest option, because that is definitely nice when you don't have to register ever at all, and you can just supply your credit card information once at the end. But yeah, there are definitely plenty of websites, and I was actually asked to build this once, have that kind of flow where you can pretend like you're registered until you do something serious, and then they make you register, but they save your existing session.
Got a question about cookies.
Let's hear it.
So when you're visiting a site, and or say you visit several sites, different domains, each site saves or puts a cookie, or your browser saves cookies for each different domain, or maybe several cookies. When a server is sending, what is it, the response with the cookie, and then the browser is sending a next request with that cookie that the server asked for, is it also sending all the other cookies, or just does the browser know like which cookies to send?
Yeah, the browser should know which cookies to send. It should be all the cookies for that domain.
Only for that domain though.
Right.
Okay.
So like when I'm at GitHub, every time I go to GitHub, it's sending all my cookies for https github.com. So it doesn't matter if I'm in Romeo Platoon or Quebec Platoon or the curriculum or demos and notes, it's all the same domain. It's all github.com. So anything within github.com, my browser is going to resend all of the cookies it has for github.com.
I'm not 100%, but I think the browser's pretty strict about that. Like running JavaScript in the console, like right now on the GitHub website, I'm not sure if we could even get cookies from some other domain or site.
I mean, yeah, in general, document.cookie, oh, not even in general, all the ways, document.cookie will only show you cookies for that current domain you're on. So this is, what GitHub knows about. I'm guessing that _octo is my GitHub session ID. Oh, and they even saved my time zone information. So I guess time zone kind of makes sense to store in a session or just like in a cookie, because like from one login to another, I might have a different time zone, if I'm like traveling 1 week to the next. So you might not want to save that in the database because that can change unexpectedly. But probably from one page load to the next, like within minutes, that's going to be in the same time zone, unless I'm like in my car driving 80 miles an hour while using like 5G or whatever. So I guess it makes sense that time zone is something you would want to store about a user for minutes or hours, but not like days or weeks. So yeah, we've gone over a little bit. Do people have any more questions, or are we ready for lunch? All right, sounds like everyone has asked all their questions. So thank you very much for paying attention, following, listening, being engaged, asking questions. Love it. It's one of my favorite topics to talk about, just because I think it's cool and interesting, and most people don't know very much about it. So, you know, if you feel like you have a solid handle on this stuff, you'll have an edge over many other junior developers. And yeah, if there are no more questions, I will conclude today's lecture. See you this afternoon. Thanks, folks.